have you on board. Thank you.
Thank you, ma'am. And still, I have to learn lots of things, and still, I am learning. So, with this, thank you a lot for this great introduction. And so now let me share the screen. Is my voice is audible?
You are audible, and yes, your page is
Screen is
also
audible.
visible. Yeah.
Okay. Thank you. So, good evening, everyone. So, in this lab session, we will discuss the demonstration of a popular clustering algorithm, which is k-means, and also we will see how to apply it on different sampled data sets, or how to apply it on some real and synthetic data sets. I have already uploaded the folder which is named as day 4 underscore lab session on the shared folder, which is on the Google's Drive. So here in this folder, you can see a Python notebook file which contains the code related to the k-means, and inside it there are two more directories. One is the named as real and one is synthetic. This real contains some real world data sets, and this synthetic data set contains two-dimensional toy data sets, which will be useful to analyze on what kind of data sets any particular clustering algorithm works or how it performs. And also it is these kind of two-dimensional data sets are also helpful um, in analyzing or in developing a particular algorithm on the basis of your specific requirement. So first, for the first step is to download this folder. So click on this day 4 underscore lab underscore session folder, and okay, right click on it, then click on this download. So a zip file will be downloaded. Okay. So here a zip file will be downloaded. Okay, so now this zip file is downloaded. So go to your system in which the folder is this zip file is downloaded. Unzip this. Unzip it. Okay. Now in the next step, we have to upload this folder. This folder on our Google Drive. So go to the Google Drive. I'm uploading it inside this collab notebooks folder. You can upload it on any folder. It is depend on you. So click to upload it. First click on this new icon, which is on the top left below the drive icon. Then click on the folder upload and select the folder from your computer system to upload it. My drive folder and click on it. Okay, so all the files of the folder is uploading. So this is the folder which is uploaded. Inside it, this is the Python notebook file. This is the notebook file in which you can do programming by self. And here you can see that these are the codes related to the k-means and how to load the data sets and analyzing it. So I'm requesting all of the participants to give me response that whether you are able to upload it, the folder on the Google Drive or not. If yes, then please you can write done in the response. Is anyone uploaded the folder and able to open this notebook file? Or I should demonstrate it once again? Okay. Let me let me see it for a couple of minutes. Okay, thank you for the response. Okay, my voice is feeble. Mm, okay, let me change the then voice setting. Okay, some of you have written uploaded. Is my voice better now? Okay, thank you. So, yeah. So here in this file, this is the notebook file in which the code is written in the Python language. And for the demonstration and
May
for
I
the
say
better,
something here, Atif?
yes, ma'am.
May I say something here? Uh, Request Neha or Durgesh to please allow participants to unmute themselves. If you look at here, participants, right? You just please allow them, and whenever you find that there's somebody who has unintentionally opened his mic and that is creating a problem, then you can mute himself, right? Mute him. So my request is that let's make it more interactive. People, participants would not like to write long queries, right? So let us make this interactive. All that you will have to do is to keep watching that if somebody is by unintentionally has opened his mic and that is creating a little bit of sound trouble, so please do it, right, Durgesh?
Yes,
Understood?
yes,
Okay,
ma'am.
thank you.
Sure.
Thank you. Yeah,
Okay.
Atif, you can go ahead, please.
Okay. Let me think of one. So I have already uploaded this Python notebook. Currently, I'm using this notebook in which I will do the same code from the scratch. Okay, now I'm back, I think. Am I audible?
Yes, you're audible.
Yes, okay. So I have already shared this notebook in which there is a code, but currently I am using this notebook for the demonstration in which I will be do some part of the code from the scratch for the better understanding and for the to learn the crucial parts of the program. So first, we need to we need to import the required libraries and packages. So the first package is the pandas pandas library. This pandas library will be helpful to load the data set and to perform read write operation to the data set and also perform some important analysis of the data set like statistical analysis. Because of that, I am importing this pandas library and aliasing it as PD. Another there is popular Python package which is NumPy, which is used to store the data in the form of multi-dimensional array. And also we can perform mathematical operations on those multi-dimensional array very on those arrays. So I'm importing this NumPy library and aliasing it as NP. Also to visualize the data, I am using the matplotlib library, and from matplotlib there is one sub package matplotlib. There is one sub package known as pyplot in which we can do various kinds of plots or graph plots like bar charts, scatter plots, like this. So I'm from matplotlib I'm importing this pyplot and aliasing it as PLP. So to run it, just use Control Enter, so the cell will get run. Okay, it is taking some time for connecting. Okay, so session is connected and the our first cell is run perfectly. Now, first we will see how to perform cluster analysis using k-means on two-dimensional synthetic data sets. I have already shared these some of the synthetic data sets with you. to explore more synthetic data sets or to download more data sets, you can use uh, this link which I have given, which is a GitHub repository, which is the contributed by two researchers, in which you can see various synthetic data sets. You can download these data sets from this repository also. Just click on this, but suppose you wanted to download this banana data set. So just click on it, and after clicking it, you will get this data set.
मेरा गलती से शायद रेज हो गया या क्या, इन्होंने मेरे को वो कर दिया था। अमरीन यू आर स्पीकिंग, क्या हो रहा है इसको? स्पीकिंग।
Okay. So you can download the synthetic data sets from this library. Okay. So first, to load the data set, first from the Google Drive, first we have to mount the drive so that we can perform read and write operation of the files on from those drive. So to mount the drive, you have to first click on this folder icon, or which is on the left panel. So click on this files icon, then click on this third icon, which is the same as drive. So click on it for mounting the drive. Then it will ask some permission. So allow those permissions. And now the drive is mounted and you can perform read and write operations, or you can read and write the files from your Google Drive. In your case, okay, in your case, to mount the drive, you can also run this cell directly. So your drive will be mounted by some of the access of the credentials. Okay. So here you can see that after mounting a drive, from this left panel, you can see the directory structure of your Google Drive. So here, click on this drive, and inside this drive, click on this My Drive. In this My Drive, you will see all the file structures and all your folder structures and files which is present in your Google Drive. On this, I have uploaded that folder on this collab notebook folder. So I am clicking on it, and you can see that this is the day 4 lab session folder. And inside this folder, these are the data sets. So first, we want to perform clustering on the synthetic data sets. So let us click so all these data sets are in the form of CSV file or separated by some characters. So let us click on this G12 data set. Here on this G12 underscore k equals to 3.txt data set, after double clicking on it, you can see its data or its entries on the right panel. In this right panel, you can see that there are some data entries. So in this data, each row is representing a single data point. So this is the first data point or data of the first data point or a data instance. This is the data entries of a second instance, and so on. So for suppose fourth data instance or fourth data point, so rows are representing the data points and features representing the values of those data points along a particular feature. So for fourth data point, this 0.79362 is the value along the first dimension, and 0.86982 value is along the second dimension. And here this last column is the clustering labels. So 4 data points belong to the cluster 1. Similarly, this let's say 139th data point, its value along x dimension is this. Its value along first dimension is 0.40313. Its value along second dimension is this 0.090, and it belongs to the cluster label 2. So here you can see that this data set is the 2 dimension divided by some rows and columns, in which rows representing the data points starting n-1 starting columns, this apart from last column, representing the values or representing the features, and the last column representing the cluster label. Okay, so now to read this file, we have to first know what is the file path. So to get the file path, just on this left panel, click on this G12 dataset. On inside it, click on this menu button. Here you can see there is one option which is copy path. So copy the path. So I am creating one variable and assigning this whole path into the F. Okay. Now to load the file inside the pandas library, there is one function known as the read CSV. In this read CSV function, we will majorly pass three arguments or three parameters. The first parameter is the file name. The second parameter is the separator. And the third parameter is about the header. So let's go to this G12 dataset again. So inside it, you can see that each data entry is separated by a tab. So in this case, separator is /t. In this case, separator is /t. And here you can see that there is not any information related to column. In some datasets, you will see that there will be the information about the column. Like in this case, you can see there will be written X, Y, first feature, second feature, then cluster label. In this case, we don't have any column. So we are passing header as none. And run this cell. So you can see this is the output of this code when we are reading a file. So file is read successfully. And here you can see that we can see the each data entry of a file G12 dataset. So here the pandas library is storing the data in the form of a special data structure known as data frame. So here you can the thing which you are seeing the output is in the form of a data frame, in which the data is divided into the rows and columns, and on the basis of those columns you can perform some operations, or you can retrieve the data or retrieve the statistics about the data column wise and so on. So so I am assigning this since this pd.read CSV is returning a data frame object, so I am assigning that object to a reference variable, let us say named as df. So here you can see that the synthetic datasets which I have shared or the man-made datasets, and especially made just for the study or just to develop a particular algorithm or study how the algorithm performs on which kind of dataset. And most of all these datasets are two-dimensional, so that we can easily visualize those datasets, and we can see how a particular algorithm will be performed. So here you can see this is the dataset and the data which is stored in the data frame. To print only suppose the starting rows of this df, we can use the function head, and we can suppose pass we want to see starting 10 rows. So just pass 10 here. So first 10 rows of this dataset will be visible. Now next step is to on this df we can perform also perform or retrieve the data on the basis of the indexes. So in data frame, we are generally data frame is accessed or performed on the basis of a column. So if I am typing df of 0, so it will return the first column. If I am typing d of 1, so it will return the data along the second column or along the second feature. If we want the data along the second feature of first 5 data objects, so we can type as df of 1, then colon, then 5. So we can also perform slicing on this data. So by default, on the data frame, we can perform slicing on the basis of column or column wise. In order to perform slicing row wise, we can use an special attribute of this df, which is ilog. So with the help of this ilog, we can perform slicing on the basis of row first and then columns. So here, to suppose we wanted to retrieve the data of a second row of first feature of second row of first along first column. So we can type as 2 comma 1. So we will get its result. So here, suppose we wanted to retrieve the first 10 rows. So we can type it as column 10 and the last two columns. So we can type it as 1 to last. So we will get a data frame, which is a subset of this data frame tier. So here in the next step, we want to split our data set in the split our data set by the data part and the cluster labels part. So here the first two columns are the data part and the last column is a cluster label. So to get the data part, we want all of the rows. So I am typing as colon, just colon. So it will retrieve all of the rows. And since we want first two columns, means we want to omit the last column. So we can type it as -1. -1 means the last column. So it will return the data part. If we wanted to return the cluster labels part, again, we can type it as df.ilog for indexing row wise, then all the rows, and then the last column. So it will return the last column only, which is the cluster labels. In the further part of the programming, I will use the numpy arrays to perform any logic or any operation and to perform the keying. Why? Because I find it is more convenient to perform on the multi-dimensional array because I'm used to it more. So I'm converting these data frames into the numpy arrays. So to convert any data or any particular data structure into the numpy array, we have to just pass this data into the function np.array. So I am passing this whole data part into the np.array, which will return again the matrix or two-dimensional array in the form of numpy array. So here you can see that this is a numpy array which contains the only data part. So I am also converting this labels part into numpy array and assigning it to the variable x and actual label. So here you can see the x contains the data part. To get the dimension of this x, we can use its shape property. So x.shape. So this shape will return the dimensions of this multi-dimensional array. So it is the two-dimensional array in which the first dimension is of size 300, which is number of rows, and second dimension is 2, which is the number of features. So I am assigning these number of data points and number of features into a variable n and f. Also, to perform the k means, we know that we want the value of k, which is the number of actual clusters. So to get the number of actual clusters, we can use this actual labels array. So here you can see that these are the labels of the data point. So it means that the first data points belongs to label 1. Second data point also belongs to label 1. Last data point is belong to cluster label 5. So to get to know how many different unique cluster labels are available, we have to just pass this array into the set function. So it will return a set and we will get to know how many different cluster labels are available. So in this G12 dataset, there are 3 cluster labels, which is 1, 2, and 5. To get number of cluster labels, I am just passing it this whole. I am just finding the length of set using the length function len and assigning it to the k variable. So this k contains the actual number of clusters, which we got from the dataset. So I am just printing it. Number of points is n, number of features are f, and number of clusters are k. Okay, so how many of you have completed this till now? I'm requesting you to give the response. It's better for me. Okay, thank you for the response. What about remaining participants? Okay. You can also access this drive, this Python notebook, which I have shared. In it, you will get the code if someone is facing problem. Is everyone is still doing the what about other participants? Okay, okay. Thank you for the response. So I am continuing this session. So in the next part, we will visualize this synthetic data set. So since I already told that all these data sets are two-dimensional. So since these are two-dimensional, so we can visualize these data sets into the coordinate system. So to do that, we will use the scatter plot. So I already imported this pyplot subpackage of a matplotlib. So we will use this to perform the scatter plot. So first we will define the size of the R figure. So to define it, we have to from PLT call figure function, and inside this figure function there is one argument which is fixed size. In this fixed size, we have to pass the dimension of the figure. So we want suppose 7 as in length and 5 as width. So these stats is in the inches. So our figure will be of size 7 cross 5. And then to do scatter plot from PLT, I am calling scatter plot. I'm from PLT. I am calling a function scatter, and in this scatter function, we have to pass mainly two things. The first parameter is the value of the data along first dimension or along x dimension. So we already have the data x, and we since want only the first dimension, so we can pass it as x colon comma first column, which is 0th column. Then second is x. Then the second parameter is value of the data along second dimension. So to pass it, we will just pass it as x colon. Colon means we want all of the all rows. So that's why we are passing just colon, and we want only the first data of the first column. So I'm passing it as 1. To just show the figure, we will just call it plt.show. So here you can see the scatter plot of the G12 dataset. You can also increase the size of this marker, of the marker size. So suppose say 60, and you can also change the marker type also. Suppose let's pass S. So all the markers will be of type square. So currently, let's use the default marker, and you can also pass the color also. Suppose black. Okay. Currently, let's use the default marker color, which is C0. We can also give the title to this plot also by calling plt.title function, and inside it any string or text which you wanted to be as a title. So I am passing it as input data set. So here in this diagram or in this figure, you can see that this is the scatter plot of the data set G12. So in this G12 data set, you can see there are just by visually that there can be three clusters. One cluster is this, another cluster is this, and another cluster is this. And also in this data set, we can say that all these clusters are the centroid base, because we can say that all these data points are, if suppose there are three centers, suppose this is the center one, this is the center two, this is the third center. So all these data points belong to the center, which is around here. So on the basis of centroid or on the centroid based clustering, we can perform clustering in this data set. So k-means it will be a good clustering method to perform clustering on this data set. Because by k-means we will get the minimized SSC, and those clusters which is having minimum SSC maybe have the desired clusters which we want. So here you can see that this data set containing total 300 number of data points, a total number of features are 2, and total number of actual clusters are 3. Okay. Now to visualize the data set, there is one question. Could you please tell what options XYZ are available under np.xyz or plt.xyz? Oh, for it, recommending you to, there is one question. So I'm recommending to, for the improving the practice or improving the knowledge related to the these libraries, go to or refer the actual sites of these packages. You will get the complete documentation, and you can also use this help function. Suppose there is one question that what are the different options available for NP package. So you can, there is one very good function in Python which is help. Inside this help, you can perform, you can pass this, so you will get some documentation related to it. For NP, it will be very large. So here you will get the complete documentation of NP and what different sub packages will be available in NP. So this help function is good. Without Googling it or surfing it, you can use that function. Okay. Now in the next part, we will visualize this input data set along with the ground truth cluster label or the actual cluster label, so that we can see that what are the actual cluster labels are present in this data set. So to do it again, I am just initializing the figure to set the figure size. Then again doing the scatter plot. First value of the data along first dimension or x dimension, value of the data along second dimension. And here we want to do the color map on the basis of the ground truth cluster. So all these clusters, all these data points which are belong to this cluster will have the different cluster label. All these data points will have different cluster label, and all these data points will have different cluster labels. On the basis of those cluster labels, we can visualize it. So on this C, we have to just pass the data which contains the cluster labels. So it will be to the actual label, this variable. So I am passing this actual label. Okay, so here you can see that all these data points which are having the yellow color belongs to a one cluster or belongs to a one group. All data points which are of this indigo blue color belongs to one cluster, second cluster, and all data points with having this purple color belongs to the third cluster. We can also give the title. Let's see. Input data with Brown chip cluster. Okay. So here we are visualizing the input data set, in this case, which is G12. So in which we can see there are three clusters, which is in the form of Gaussian blocks. And our task is to identifying these clusters or to identifying these groups. So as I already discussed, that k-means is one of the good method to perform clustering on this data set. So to apply k-means, first we will see the example in which we will use the built-in function of which is a built-in function of a famous library, which is the sklearn. This sklearn or scikit-learn library is a popular Python library which gives the functionalities related to the machine learning models. So from sklearn, there is one sub package which is cluster. So from sklearn, I am importing a sub package cluster. Inside this cluster package, we will get so many clustering algorithms. Most of those are the popular or traditional clustering algorithms which usually used by the data scientists and researchers. So I'm from sklearn, I am importing this cluster sub package. To perform k-means, we have to call inside this cluster package, there is one class known as k-means. To see the to see what are the properties of these classes, we can use help function, as I told. So just inside this help function, pass cluster dot k-means. So here you will get the documentation of this k-means class. So this k-means class, uh, so this k-means class will this is one constructor of this k-means class. Inside we have to pass some parameters. So to instantiate the object of this k-means class, we have to call this constructor, and inside this constructor we are passing first number of clusters. So our number of clusters is inside the k variable. So I'm passing k. Then type of init method. So there are some different methods for the centroid initialization. Currently, we will see just the most simple way of initializing, which is the cluster. Okay. So we will use the we will see the most common way of initializing the centroid, which is initializing randomly. And this n underscore init parameter is which is an integer. We have to pass an integer value positive, which will say that how many times we want to perform king. Suppose we wanted to perform king means 10 times, then we have to pass n underscore init as 10. So king means will perform 10 times, and the result among those 10 runs which have the best SSE or minimum SSE will return as the final result. So I'm just passing that number of init as 3. And then also this max iter parameter is also a very important, plays very important role in k-means. So let's say for each k-means run, it will run for maximum 50 number of iterations. So just run it. So here you can see that an object will be returned by this constructor. So I am referring this object into a variable k. Now to perform k-means, now we have set all the parameters of the k-means by calling this constructor. Now to perform k-means on the data set, we have to call from km a function fit. Inside this fit function, pass the data on which we have to perform clustering. Since our data is to the x variable, so I'm passing x variable. So k-means will be performed on this x variable, and the parameters like the final centroids and the final labels will automatically assign. So k-means is run on this dataset X successfully. Now, how to get the labels predicted by this k-means? So here you can see that there are some attributes. So here in this attribute, you can see there is one attribute labels underscore. So this from K, this labels underscore attribute will return or the labels predicted by the k-mean. So here you can see that the k-means predicted first data point as label 0, or we can see that all these data points, starting data points, uh, are assigned as cluster 0 by the k-mean and so on. So I am assigning it to a variable predicted label. So this is the labels predicted by the sklearn's k-means method. Label. So here you can see all the predicted labels. I think there are some doubts. Okay. Sir, how to calculate all the 3 input data set cluster efficiently and accurately? Okay, actually, in case of k-means, it is depending upon the uh, centroid initialization. But for most of the cases, the data set will be varied for the different runs of k-means. So it will be better to run k-means multiple times and select that case which will give the best result or minimum accuracy. It is the one of the most popular way to do this. We will see this thing later. Okay. Now, in the next part, we will visualize our results, which are or clusters predicted by the k-means. So to visualize it again, I am just initializing the figure type. Then I have already do the scatter plot. This is the scatter plot for the actual cluster labels. Now we have the predicted cluster label. So we can pass inside this C. We wanted to know what clusters are predicted by this k-means algorithm. So those cluster labels are inside this predicted underscore labels variable. So I am passing this as a parameter for the C keyword argument. Then let's say title as uh, cluster predicted by k-means. Then PLC dot. Okay. So here you can see that this sklearn k-means method perfectly grouping the data set or perfectly grouping the data set which we want. And these labels, most of the data points or cluster labels of these data points matches with the cluster labels of the actual cluster labels, matches with the actual cluster labels. And here you can see the uh, results of the k-means algorithm and the groups which is formed by the k-means for the input data set, which is a G12 data set. Okay, is there any doubt till now, or is anyone doing everyone doing this thing? Facing facing any difficulty? You can write on the chat. Yeah, I think there is no doubt. So, and is everyone doing this thing? If uh, if if uh, if I'm requesting to participants, those who have completed till this part, please type done if possible. Okay. Okay. Thank you for the responses. So let's move to the next part. So here in this, so in the previous example and the previous clustering analysis, we are using the inbuilt k-means function. In the next part, we will use the k-means function, which is a user-defined function, so that we can see the detailed step of the k-means and how in each iteration the k-means is converging to the local optima. Or so to do that, first this is the function which we defined known as cal_ssc. In this function, there are three parameters. First parameter is the data. Second parameter is the cluster data or the cluster label. And third parameter is the centroids. So you can also plot the centroids also. So here, this from KM to get the cluster centers, you can call this cluster underscore centers underscore attribute, which will return the final cluster centroids after the fitting of the k-means algorithm for the input data set. So I am just also plotting this cluster centroids also. So this is an array. So I am just passing km dot cluster center, and again in this scatter plot we want on the first as a first parameter we want to give the value of the data along the first dimension. So again column 0, and in the second parameter we want to give the value of the coordinates of the cluster centers along the second dimension. Okay, so I am giving it with assigning the different marker. Let's use star and size as 100 and color as so here you can see that the also see the clusters, final cluster centers after the fitting of the k-means on the input data set. So these are the final cluster centers. Yes, so I was talking about the SSE function. So this sum of squared error function, as discussed in the lecture, is nothing but finding the closeness of each data point to its cluster center or to its centroid, and doing the sum of all those closeness or distances, square of those distances. So for that, so suppose we wanted to find the SSE of this final cluster center. So we can just call this call underscore SSE function. Inside it, first parameter is the data. So I'm passing X. Second parameter is the cluster label. So our cluster label is inside the predicted label. And the last parameter is to the centroid. So our centroid, as I already told, that is to this km dot cluster center. So by calling this this user defined function call underscore SSE, it will return the SSE value. So how SSE value is calculated? So inside this function, first two variables is initialized. One is the SSE, which will store the SSE of the data set or the cluster. Then second is this underscore I variable to access which will be helpful to access the centroids one by one. So centroid underscore I will return the so if centroids of 0 will return the centroid of first centroid. Centroids of 1 will return the second centroid. So here in this for loop, I am iterating to all the unique cluster labels available in this cluster data. In our case, we are passing since this predicted labels. So this set of predicted labels will return 0, 1, and 2. So in first iteration, value of I will be 0. Second iteration, value of I will be 1. And third iteration, value of I will be 2. To calculate the SSE, we have to find the distance between all the data points of a particular cluster to its centroid. So let's say for cluster 0, we want to first retrieve all those data points, those belongs to the cluster 0. For that, I am using this np.where function. So let's call this np.where function. This np.where function is used to retrieve the indexes or used to retrieve the data on the basis of some condition. For example, we wanted to find all those labels or all those data points whose belongs to label 0. So I am just passing a condition inside this np dot where predicted labels equals to 0. It will return all those data points or indexes of all those data points which are belonging to cluster label 0. Since we want the data part, so that's why I am passing it inside this X, since X contains the data. So all the data points which are belongs to the cluster label 0, we got those part. So this part retrieving all the data points. Suppose for first iteration value of I is 0, so it is retrieving all those data points which belongs to cluster 0, finding the sum of square of difference along each dimension using this np.sum, and finally adding it to the SSC variable. So this cal underscore SSC function is let's see. So this cal underscore SSC function is used to calculate the SSC for the given data set, given cluster and their centroid. This cal underscore SSC function will be helpful for this user defined my k-means function. So let's see how the code of this my k-means function. So this, since in the lecture it is already discussed the algorithm of the k-means. So this is the simple steps of the k-means algorithm, which mainly requires number of cluster, and we can also set the maximum iteration. So the first step is to initialize the centroid. So in this case, we are initializing the centroids randomly. So here in this third parameter, if nothing is passed in this parameter init underscore centroids, means the centroid is not passed manually or externally from the user, then it will come to this part, and inside this part, the centroids is assigned randomly. So what it is doing, in the 7th line, the data of X is copied to X1. Then this is X1 is shuffled randomly so that we can select random data points. And inside this random shuffled data point, which is X1, we are accessing first K data points and storing it into assigning it into the init centroids variable. So this init centroids variable will contain the K random data points. If this parameter is passed or the coordinates of the init centroid passed externally, then this goes to this else part, and in this we are just converting this init centroid because it can be in the form of list. So we are converted it into the numpy array. In the next part, I am initializing the again. So in the next part, this init centroids is the data of this init centroids is assigned to this centroids variable. The dimension of its centroids variable will be, or the number of data points will be n cross k, because since our data set will contain k clusters, so sorry, its dimension will be k cross f. So since our data set will contain k clusters, so we will also have the k centroids, and also and its the features will be f. Number of features will be same as f. Okay. So in the next, after initializing the centroids, the next part is to iterating till the maximum iteration or until we will get the same consecutive centroids. And each iteration, there are 2 steps mainly. The first step is to determining the clusters by assigning each data point to its closest centroid. And the second part is to find the new centroids by taking the mean of the cluster. So to perform this, so to assign the closest centroid to each data point, I am firstly calculating the Euclidean distance between the data points and the centroids. So it will return a distance matrix of a dimension n cross k. So if you wanted to find the distance between ith data point, and jth centroid, so we have to just use distances of I comma j. So to get the closest centered of each data point, I'm just using this dot arguing function, which will return the closest cluster centroid for each data point and assign it to its clusters. In the next part, next step is to recalculate the centroids, which on the basis of the new clusters. So for that, again iterating for the k times, because we are having k number of clusters, and fetching all those data points which belongs to this cluster number. So for first iteration, value of cluster number will be 0, suppose. So it means that we have to fetch all those data points which are belong to the cluster label 0. So in that case, I already discussed, we can use this np.where function, and to get the data part, we can pass it inside this x. So we will get all those data points which belong to the cluster 0 for first iteration, or where when cluster number value of cluster number is 0. It is assigned to this variable point, and next step is to get the arithmetic mean. To get the arithmetic mean, I'm calling this np.mean function, and inside that we wanted to find this mean of this points variable. So I'm passing points, and we want it along each column. So that's why passing x is equal to 0. So let me demonstrate it how this is working. For example, as I told you, we want all those data points. Means, let's say currently we have predicted label which belongs to the cluster 0. So it will return the indexes. We want the data part. So we are passing it inside X. So we will get all those data points which belongs to the cluster 0, and we want mean. To calculate the mean, we can call this mean function. This whole data is in the form of the numpy array. So we can use the functions of the numpy arrays. So we are calling dot mean function. So just passing simply mean or just calling the mean function, it will return only one value. We want the value of mean along each column. Let's see. Okay, let's print only first 10 data points. So we want to find the mean. We want the mean, or we have to find the value of the mean along this first dimension, then value of the mean along this second dimension. So by calling just mean function, we will get the single value. Means it is calculating the mean of the whole data. We want to perform mean column wise. So I am just passing axis as 0. So by this, we will get the centroid or arithmetic mean column wise of the data. So that's why this is called as np.mean. Then for point data set, we want it to calculate the mean and along each column. So that's why second parameter is x is equal to 0. And it is assigned to this new centroids function. So it will calculate this new centroids. It is assigned to this new centroids variable. So this new centroids variable stores the new calculated centroid. To calculate the SSE of each iteration, I'm just again calling this cal_SSE function. First parameter is data set, second parameter is the cluster label, and the third parameter is the new centroid, which is calculated. Okay. The next, and this is the termination condition. If there is no change or difference between the new centroids and the previous centroids, it means that its value will be 0. It will return a 0 value. So if condition satisfies, then loop will be break, and means that the k-means clustering algorithm is converged to its local optima or global optima. And finally, it is returning some important it is returning some important variables. First is this clusters variable, which will contain the labels predicted by the k-means function. Second parameter is the initial centroids, which is assumed for this call, and the third parameter is the centroids function, which is the final centroid. These are just for the visualizing purpose. So this part of the date, these part of the code are just visualizing it. results of the k-means along each iteration so that we can study how k-means converges for the particular data set. Or we can visually see how will k-means converge to for a particular data set for the given or for a particular initial centroids. Okay, so there is one doubt that how to separate multiple clusters into individual image clusters. Sorry, I didn't get this question. Sorry, I didn't get this question. The next question is that every time new centroid is assigned by user to determine the dimension. No. To determine the dimensions, this f variable already contains the dimension, and we don't. The code itself is independent from the number of dimension. It will do automatically. So user don't. It is not required by the user to determine the dimension. We will see the case for the multi-dimensional data sets also. So first let me run this. So, so to call this user-defined function my_k_means, just call my_k_means. In its first parameter, you can see that its first parameter is all these are the parameters. So the first parameter is x, second parameter is k. We want to randomly initialize the centers, so no need to pass this parameter. Let's set the maximum iteration as 20. And since we want the visual plot of the k-means for each iteration, so I'm passing it as true. It is returning 3 things. So I'm assigning it to this one. Okay. So here you can see the step-by-step visualization of the k-means algorithm for this input data set. So here in this case, you can see these red markers, which is the star markers. These are the random centroids, which is initialized by this k-means. So here you can see that this is the first centroid, this is the second centroid, and this is the third centroid. Then for each iteration, there are two parts. The first part is to assigning each data point. It's assigning each data point to its closest centroid. So let's say this point. So currently just focus on this red marker, ignoring this blue marker. So here you can see that all those data points which are of green color are closest to this centroid or this marker. All those data points which belongs to this yellow cluster are closest to this centroid. And all those data points which belongs to purple cluster or which are having the data points of purple color are closest to this centroid. So for iteration 0, its first part is which is the assigning the centroids to its closest data point. We can see its result by these 3 different colors. Now the next part is to recalculate the centroids based on the new clusters. So here you can see that in the first part of this iteration 0, we got 3 clusters, which we can see. And you can see that after formation of clusters, its actual means is shifted, which we can see it by blue color. These are the clusters which is formed on the basis of this red marker or red centroid, but now its new cluster centroid is this. For this yellow cluster, it is formed on the basis of this centroid, but now its new centroid is this. For this cluster, which is formed on the basis of this centroid, its new centroid is this blue marker. So it's the second part of iteration 0, which is calculating the new centroid or recalculating the centroid for the new cluster. So here you can see that for iteration 0, these clusters are formed on the basis of these clusters, which is in the red color, and these blue clusters are the new centroid. So for next iteration, these blue markers will act as the initial or will act as the initial centroids for iteration 1. So here you can see that Okay. So here you can see that in second iteration, these are the new clusters. These red markers are the new clusters for the iteration 0. So for second iteration, again, the same two steps is happening. So all these data points, which belongs to the green color, are closest to this centroid. All data points which belongs to the yellow clusters are closest to this centroid, and all these data points which are of purple color are closest to this centroid. Again, the next step is to recalculate in the same for the same situation. Next step is to recalculate the centroid by taking the arithmetic mean. So you can see that again these blue markers are the new centroids of these clusters, which is formed during iteration 1. So for the next iteration, we can see that all these red markers again are the centroids at the beginning of iteration. On the basis of this, again the better clusters are formed, and again these clusters are recalculated. Their centroids are recalculated. Here in this iteration 2, you can see that we got these clusters perfectly. This cluster of green color perfectly. So here you can see that both these two centroids is collided. In this case, there are still some changes. So in the next iteration, finally we got the clusters. Also, it is the good cluster, and also we can see that there is no difference between the previous centroids and initial centroids. So in this case, our k-means clustering algorithm got terminated. Also, here we can see that SS k-means work on the basis of SSE. Its objective function is to minimize the SSE. So here you can see that a value of the SSE after each iteration. So after iteration 0, its SSE is 18.2561. Then for iteration 1, its SSE becomes more lesser, which is 5.01. And here we can see that after increasing the iteration, the SSE is become lesser and lesser, and at the end we got the cluster which is having the minimum SSE. Also, we can see that for iteration 2 and iteration 3, we got the same SSE. So also the k-means should terminated, which is happened same in this case. Let me run this k-means once again. So you okay, this is the case for bad initialization. We will see this later. So this is another example of the k-means for the given data set. So this is the centroid which is initialized in the beginning of k-means. Then on the basis of these three centroids, the clusters are formed. Then new centroids are calculated. Then on the basis of these new centroids, again clusters are formed, and then again new centroids are calculated. And again on the basis of these three new centroids, again clusters are formed. And again the step is happening until we got the two same or two centroids. So here you can see that in each iteration, the results of k-means is converging to the better and better result, and SSE becomes lesser. Okay. So this is the example of applying k-means on this dataset X by visually plot each step. So just to simply call this k-means without any without any visualization. So just call this my k-means function X, number of clusters xk, max iter again 20, and it is not required to pass this last parameter, or you can pass it as false. So let us can print this clusters variable. So you can see the clusters predicted by this user defined my k-means function. So again, I am plotting it. So you can reuse this previous page. This is now to the cluster region, and the final cluster center is holded by the center region. Okay. Uh, Now, here we will see a example in which, since you all know that the results of k-means can vary on the because it is depending upon the centroid initialization. For different centroid initialization, it will give different results for a same data set. It can give different results. So here, this is an example of the clusters produced by the k-means in which the centroid initialization is good, so that we and because of that we got this good clustering result. And in this case, this is an example of the bad centroid initialization, or a case of centroid initialization in which we didn't get the desired clusters. So in these both these plots, the blue data points or the blue markers are the initial cluster centers, or the cluster centers which is assumed as the initial. And on the basis of this, k-means will run, and we got these results. These red markers are the final cluster center. For this case, bad central initialization, you can see that this is the first initial center, this is the second initial center, this is the third initial center, and for this case, we got the bad clustering result. So here you can see that this is the one example in which the results of k-means may vary, and sometimes you may be not get the desired result. So for that case, it is advised to run k-means multiple times. Okay, so suppose we are running k-means 10 times, and among all those 10 runs, select that cluster, or select that those cluster labels for which we got the minimum accuracy. So this is the code for that. So I'm initializing two variables, best labels and the best underscore SSC. Best underscore labels initialized as none. Since we want to get SSC, we want to get clusters results which is having the minimum SSC. So currently I'm initialized it as an infinite value. Let us run it for 10 times. So I'm running this k-means function for 10 times for the given input data set. And then in the next part, I am calculating the SSC using cal underscore SSC function. And if we got the better SSC or lesser SSC than this best SSC, so the best labels and best SSC is updated, and finally giving the visualizing the results of these best labels, or the labels which are corresponding to which we got the minimum SSC. So here you can see that in this case, we got the k-means result in which we got the minimum SSC for each these 10 runs. We can also print the SSC for each run. So we can type it as for iteration. Let's say iteration number SSC is okay. So for iteration 0, SSC is 3.83. Here you can see that we also got the case in which we got the poor clustering result. So among it, it is selected the best result, and we got this result. Okay. Is there any doubt in now? Okay. There are some doubts. There is one doubt that minimum how many random centroids are assigned or generated for each cluster. So the number of centroids will be same as the number of clusters, which is k. In this case, the number of clusters are three. So randomly three cluster centroids will be initialized. For object detection, can we apply the clustering? Actually, object detection is the different task. I think most probably it will comes under the classification. So classification is a different task which comes under the supervised learning. In K-means, our aim is to just uh, identify the similar groups without considering clustering labels. Here you can see that in this code, we haven't used the any actual cluster labels while detecting the groups or similar groups or clusters. So object detection is different thing. Grouping, okay. Okay, so let me do the remaining part, then I will give the answers for the remaining query. So in the next part, we will see the clustering. We will see the k-means, how to apply k-means clustering for the real data set. So again, uh, this real folder contains some of the real data set. You can download other data sets also, or these data sets from this UCI machine learning repository. And here you will see these data sets like wine, heart, iris data set. So you can download more data sets from this repository. So again, let us say we wanted to do cluster analysis for this iris data set. So I'm double clicking on this iris data set. As I told you, for to load this data set, first step is to get the file path. To get the file path, click on this menu icon, click on this copy path, then F9 as this is the file path. So to read the file from PD, call read CSV function, pass its first parameter as F9. Second parameter is a separator. Here you can see that in this iris data set, the data entries are separated by this comma. So I am passing comma, and also in this data set there is no column or header, so I am passing it as header as none. Suppose there will be some column. Suppose in this data set, in synthetic data set, there is aggregation data set. In this data set, you can see the header also. So in this case, you don't have to pass this parameter. Avoid this parameter. So again, go to this iris data set. So assign it to this df variable and distancing the first 10 or 15. Okay. Now, again, I am converting this, separating the data part and the cluster label part, and also converting those data frames into the numpy array. So to get only the data part from df, use this ilog property for indexing. Since we want all rows, so pass it as colon, comma. We want first 4 columns, or we want to omit the last column. So I'm passing it as from starting till second last. Then df dot ilog. Then again all the rows, and we want only the last column. So I'm passing just -1. Converting these two into again the numpy array and assigning them to the x and the label. Let's see, it should be actually. Again, n comma f will contains the number of data points and the feature. And to get the number of clusters, again, we have to convert this actual labels into the set. I already discussed this thing. And to get the number of clusters, actual clusters, I just call this length function. N, F, so here you can see that this data set contains total 150 number of data instances, in which there are total 3 number of cluster labels. Each cluster labels is having 50 number of instances, and actually this is the very famous data set which is used which is very common, and this is the data set of the iris plant, and each cluster label belong to one category of, and it is columns containing the information related to the sepal length and sepal width, or the length and width of the petals. So again, to apply the key means, we can use this. We can use either this inbuilt function or user-defined function. So I am using this inbuilt function. Okay. So just call again this cluster.kmeans constructor, pass some parameters like number of actual clusters, now initialization method, how many times you wanted to perform k-means, and maximum number of iterations. Okay, so here you can see that these are the labels predicted by the key for the data, for the iris data set. So these are the clusters predicted by, this is the cluster label for the first data point, this is the cluster label for the second data point, and so on. Since this is the high dimensional data set, so we can't visualize it simply just scatter plot because it is more than 2 dimensions. So we can't do visualization. So but we can say that these are the cluster labels for this input iris data set. How to perform this clustering? Now the next part is, or one of the next important step in clustering is to evaluate the performance of a particular clustering algorithm for the given data set. For the synthetic data set, we can see clearly that.
Atif, we have 1 minute.
Okay.
So if you wish to do it, we will share your Google Sheet. I think you have already shared. So just do the analysis, and then we will have to stop, because the faculty members must be now tired. So although your session is going on very well, I'm really finding it so interesting. Just wanted to tell you the time that we are, time limit that we have. Okay.
Okay, ma'am. Okay, sure, ma'am. So I'm just wrapping it by this is the last part. So for the cluster analysis, or to check whether the given labels or predicted cluster labels are good or not, we can evaluate it by 2 ways. One is the internal measures, and another is the external measure. In internal measure, we don't use the actual cluster labels. On the basis of the cluster labels and the data behavior, we will evaluate that whether those clustering results are good or not. One of the common internal measure we already discussed, which is the SSE. So to calculate the SSE, you have to just call cal_SSE function, pass this x. First parameter is x, second parameter is cluster label, which is inside this predicted label, which contains the cluster labels for each data point, and third parameter is the cluster center. To get the cluster center, cluster_center. Okay, so here you can see this is the SSE, final SSE for this predicted labels. The minimum the SSE means better is the clustering result. Another way of performing the measure is another category, which is the external measures. In external measure, we also use the actual cluster labels for the clustering evaluation, and we just compare the actual clusters and the predicted cluster labels. So the first way which will we see is to use the clustering accuracy. It is one of the validity indices to measure the clustering performance by comparing the actual clusters and the predicted labels. So this is one function, clustering accuracy. It contains the code of to calculate the clustering accuracy. So just call this clustering accuracy function. The first parameter is the actual label. First parameter is the clusters predicted by your clustering algorithm. So in our case, it is assigned to this predicted label. And second parameter is the actual cluster label. So I'm passing actual label. So here you can see that we will got the clustering accuracy. This clustering accuracy differs slightly from the classification accuracy, which is discussed yesterday. So let me print here. So I am again calling this clustering accuracy. So here you can see that this is the classification matrix or accuracy confusion. Sorry, you can see this is the confusion matrix, which is mapping the actual labels to the predicted cluster labels. But in clustering, there is by to evaluate the cluster labels, there is one challenge, which is that here you can see that suppose in this case. Yes. In this case, you can see that suppose this is the actual label. Okay, so this is the ground truth cluster, in which this is of the clusters belong to the yellow color, blue color, and purple color. And here you can see that clusters predicted by the k-means. So you can see that although this k-means correctly identifying the cluster, but the cluster labels are mismatching. It may be possible that this cluster actual label cluster label for this cluster is 0, but our k-means is predicted it as 1. So there is this mismatching in the cluster labels between actual and predicted. So this is one of the challenging while calculating the while evaluating the clustering validity indices. So to do that, after getting this confusion matrix, the next task is to shuffle these columns such that the cluster accuracy will be maximum. For that, we are using this linear assignment function. So it is assigning or shuffling columns such that we will get this diagonal maximum, means we will get the maximum accuracy. This value of the clustering accuracy varies from 0 to 1. So 1 means the perfect clustering, 0 means the poor clustering. There is also another popular validity indices, which is the RAND index, which is the last thing. It is also an external performance measure. So just call RAND score. I think I have already imported this function RAND score. Again, it required these two parameters because it is an external measure, and Rn. So this is the clustering accuracy, and this is Rn. Okay. So that's it from my side. I think there are some doubts also.
So I think they were asking questions all in between, but still, if there is any doubt, please
Okay.
ask.
There is one doubt that how to get the only cluster plot among 3 clusters with best performance and accuracy. I think you have to use some kind of performance measure. I mean, if you wanted to use internal measure, internal performance measure, then you can use SSC or other measures like silhouette index. Or for external measures, you can use this clustering accuracy or RA. Okay.
So Collab notebook is already shared. So yeah. It seems that the questions are all over. So I mean, I'm happy to see that participants were really participating with you, and so that is the best part. Atif, thank you so much, Atif, and